Hi, welcome to another video. Today I'm going to be discussing SD cards and the FAT32 file system. If you're not familiar with the FAT16, it would be an idea to go and have a look at my previous 3 videos first. So this video, FAT32 on a 16 gig SD card up here in the corner, and same as before, I'm using the HXD program to look at the files. So hopefully you'll appreciate it's taken me days to compile all this information and test it. Hours and hours scrolling through pages of junk on the internet. I've opened this boot sector in Paint just so I can add some notes. To find various files on the disk, you need the boot sector. And with all these numbers that are little endian, so least significant number comes first, or most significant number comes last, you need these numbers to locate the files. And with these numbers there are specific calculations to get to those files. One of the most important files to get to is the file allocation table. And you'll see here the file allocation table, FAT32, it's actually the same as FAT16 as well, starts at E and F. So that's 14 and 15. So if I show you on Windows Calculator, if you've seen my previous FAT16 videos, you'll be able to work these out in your head. Start sector for FAT1, including reserved. These numbers actually refer to the reserved sectors, but since the file allocation table comes immediately after all the reserved and hidden clusters, you can call it the start sector for FAT1. I'll clear that up. So, Windows Calculator, Standard Scientific Graphing Programmer View. We want hexadecimal. Remember all these numbers hexadecimal. Most significant comes last, so 0A. So that's A. And then 64. There we go. 2660. So that means the file allocation table 1, because there are 2 copies, noted by this 2 over here on the left. The first file allocation table is at sector 2660. All these numbers refer to sectors, only the file allocation table and then specific details in the root folder refer to clusters. So what surprised me was Rhode Island in their calculations had sectors to FAT. That was written down. Given the fact that there are usually at least 2 FAT tables, is that sectors multiplied by 2 because there are 2 FAT tables, or just sectors 2 FAT? But no matter what I did, I couldn't get this, along with some other formulas, I couldn't get it to find my root directory on a FAT32 file system. So if you need prior knowledge before looking at their documents on the internet, I don't think that's very good. The calculations should be there in front of you. What also surprised me, let me pull up this document. Florida State, don't know what year it was, week 11. It's free on the internet. Obviously for the people taking these classes. So you think, well, this must be good, it's Florida State. Go down to page 7. Byte, 8 bits. Most of you should know that by now. Sector, smallest addressable unit on a storage device. Usually this is 512. Correct, you can make it bigger. You wouldn't want to, that makes your device less compatible with other card readers. FAT stands for file allocation table. Correct. Cluster, FAT32 specific term. No it's not. Here we are, I put my 2 gig card into this computer. Format. You should recognise the capacity, less than 2 gigs. FAT16 does not support cards larger than 2 gig. File system, FAT default, NTFS, exFAT and FAT32. This is FAT16, not FAT12. Allocation units, oh hello, 32 and 64. That was one of the disadvantages with FAT16. You could only have large clusters. If you put a file in a cluster, that's it, it's full up. 32 and 64. So 32 kilobytes is a lot of sectors on a small card. Obviously once you start getting up to 16 gig, 32, 64, that's less significant. This is allocating 32 kilobytes per cluster. Pull up Windows calculator. 32,000 divided by 512 bytes per sector equals 62. There are 62 sectors per cluster. 62 is a large amount. Put one file on it, that's it, it's full up. I can make the cluster even larger. I can make it twice as big. So 64 kilobytes, that would obviously be 124 sectors per cluster. It's not an advantage to make the clusters big. It's better to make them small. But then your file allocation table gets large because your files might be spread over many, many clusters. So your file allocation table reads the file location in clusters. There's one part of data in the root directory that gives you the name of the file. That also tells you the starting cluster, not the starting sector. So if you're at Florida State and you give me this answer, you've just failed that question. So with all of that said, I'm just an end user trying to understand the numbers to get something to work. So I haven't got a pretty table as per the 16-bit FAT, so you have to look at this and count for yourself. I've said time and time again, every number starts at nothing, not 1. So nothing to 15 is 16 bytes long. So this top row, 16 bytes, second row, 16, 16, 16. I'll swap the SD cards on this computer and put the original 16 gig file back. This is the 16 gig. What have we got? John B bitmap, Paris bitmap, and new PIX resources. I've mentioned these in a previous video. One bit of data on the internet said this number 2, which is actually the root directory sectors, I don't understand this 2, because I do not need this number 2 to find my root directory. Now the root directory contains the locations, the initial locations to all your files. So to find the first file allocation table, so FAT1, we look at E and F, so 14 and 15, 64 and 0A, little endian, 2660 decimal. So 2660 sectors is the start for my file allocation table 1. I made an error earlier. I said hidden clusters. I meant hidden sectors. So the start for FAT1, including the reserved and hidden sectors, is 2660. That's decimal. This number in yellow is meant to play a part, and I do not have the answers. But this number in yellow is root directory sectors. However, it doesn't seem to apply to this FAT32 16 gig SD card. So the file allocation table is at 2660. This number in green, that's important. This number in green, so it's 32 bits, little endian, don't forget. It's the amount of sectors given to each file allocation table. And in my case, so little endian 0000 3ACE equals 15,054 sectors. Let me go to standard view so not to confuse you. So decimal numbers, not hexadecimal. So 2660 plus 15054. It's actually times 2 because there are 2 file allocation tables. So add that again, 15054 equals 32,768 sectors. But so let's look at 32,768. Open my 16 gig card. There we are. That's the boot sector, which is always 0. So we saw the FAT1 at 2660, sector 2660, enter. That's the file allocation table, the first one. Now I don't have an answer for all these FFFFFs. What I do know is at position 8, this number 7, that is cluster 7 for the first file. However, ignore that for a minute. So this is the file allocation table. It doesn't start at 7, but we've got 7, then 8, then 9, then 10, then 11, 12, 13, 14, 15, 16. You can see that's counting in hexadecimal. So it's a large file, so it's spanning many sectors. And what I do know is, if we keep on going up through all these sectors, it's a large bitmap. That's why it spans so many sectors. The last cluster, sorry, if I said sectors earlier, I mean clusters. This 63 is the last cluster, and I know that because the next number, FF, 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 OF, means it's the end of the file. At 63, hexadecimal 63. So this number 7, I said it refers to a cluster of the file, but it's not the first. Well, which one is it then? We worked out by adding 2660 plus this number 15054 times 2, we got to, up here in the sector block, 32,768. There we are. So that is the name of my SD card, 16 gig John. Then you've got some, I don't know, system info. There's, alright, so Paris 1 is the first file. Paris 1 bitmap. Each entry in a file allocation table, I'm assuming it's still 32-bit because it looks like 32-bit here. So 32 bytes per entry. Paris 1. So this spells Paris. And then if you haven't seen my other videos, this is the BMP. This is the file size. And I made an error in one of my previous videos because I was working out the date here. And it's back to front. This is the date. This is the time. Oh, I said this was the time. It's not. This number 6 is the first cluster of the file. So you can come here. Right, there's the first cluster of the file, cluster 6. Then go to the file allocation table. It tells you the next cluster. And the file allocation table then tells you all the relevant clusters for this file. So the first cluster is there. That's the only cluster mentioned in this root directory. As I said, these 4 bytes, same as FAT16, that's the file size. In fact, let's work it out while we're here. I think it's 800 by 480 bitmap plus a 70 byte header. So we should be 768,070 maybe. So program review. So little endian, don't forget. So 0 B. Oh, help if I get a hex. 0 B 8 4 8. There we are. Oh, I was 2 digits off. So now we are at the root directory. 32,768. Well, how do we find the first file location, like for this Paris 1 bitmap? So cluster 6. Go back to our table. Hopefully I haven't changed this SD card since I last used it. Right, so 15, 14, 13. Hexadecimal 13, 0D, that number 10, sectors per cluster. 10 hexadecimal 16. So I have got 16 sectors per cluster with this current format. Back to the root directory. 16 sectors per cluster. Pull up the calculator. I've got it on standard view so I don't keep on entering the wrong number in hexadecimal. 16 sectors per cluster. I haven't got a pen and paper to hand. Multiplied by this number subtract 2. Let me do it and then I'll tell you why. So 16 times 4 equals 64. I believe, and it works, so I believe you have to subtract 2 from this number because we've got 2 FAT tables. I don't know a definitive answer, but when you find this cluster, you do always have to subtract 2. So 4 times 16 equals 64. We are at 32,768, so if I add 32,768 equals 32,832. Let's go there. In the sector block, 32,000, I've forgotten what it was because I'm talking, 832, 32,832. You know this is correct because the first 2 bytes of a bitmap header confirm it's a bitmap by putting a B and an M there. And we've got the B and an M. So this is a bitmap header. At location A, we've got 46, which in decimal is 70. Let's check that out. Programmer view, hexadecimal 46, 70. As I said in the previous videos, that's the width of the picture back to front, so it's actually 800 pixels wide. So if the picture starts at 70, that means this header is 70, but they always seem to tag on 2 extra bytes, which is why the file size was 768,072, not 70. If we go back to the root directory, 32,768, you'll see this new pix res. So 4 bytes for the end of the file, and these 2. So cluster C2 is the beginning of this file. Pull up calculator, hexadecimal, 0 zeros, we can forget the trailing zeros, C2, 194. Subtract 2 equals 192, multiplied by 16 sectors per cluster, multiplied by 16 equals 3,072. So we are at, again, 32,768, so plus 32,768 equals 35,840. 35,840, 35,840, enter. Right, so I haven't looked at this one before, so this is, I'm learning as I go along. This is interesting. It's giving me the RSC, which is a resources file. You can see there. So obviously resources, the header starts with an RS. I didn't know that. And you can see I've got a few images. I think there's 10 or 11 images. Although you see 17 here and 16, I took some out so they're not in order. There's something like 11 images. Now I haven't been through the calculations of this resources file. This resources file was created with Microelectronica's Visual TFT, and it knows every file is 768,006 bytes. Right, so this last section is going to be a couple of minutes and that's it. The video is already 19 minutes long. We are back in the first file allocation table. So you saw from the root directory, the root gives you the first cluster for the first file. This file allocation table gives you the second cluster, then the third, then the fourth, fifth, sixth, etc., etc. The last location is there. Always subtract 2 from these clusters. If we go to this second file, let's work out the end cluster. So that's the end cluster, the last cluster of that file, not the end of the file. To work out where the end of the file is, just look at the root directory or the bitmap headers. Both have the size of the file. I explained that in my 16-bit FAT videos. So let's see if we can find the end of the cluster, the last cluster for the second file. It says C1. Windows Calculator. If you haven't seen my other videos, you won't know how easy it is to do this on paper without a calculator. But there you go. If you haven't watched them, you haven't watched them. If you haven't watched them, then you're not as wise as the people that have watched them. So C1, hexadecimal, C1, 193 decimal, subtract 2 equals 191 multiplied by 16 sectors per cluster. So 191 multiplied by 16 equals 3056. So 3056 on top of the sector of the root directory. So 3056 plus 32,768 equals. So the last cluster of the second file is at sector 35,824. Let's type that in at the top. 35824, 35824. Now remember, there are 16 sectors per cluster, so this is probably the top. If we go down 16 sectors, we will come to the end of the cluster, and somewhere along the way we will find the end of the file. If you want to know what this garbage is, all these bytes are colours on the TFT. The FAT system assigns the ASCII characters to their value, so it doesn't actually mean anything. This is the last cluster of the middle file, so I'm going to go, so 824, I'm counting up. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There we go. That's the end of the file. On sector 12 of the last cluster. 13, 14, 15, hello, 16, and there's the last file, the resources file. So the maths works. I'll leave you with this image. You can pause the video and obviously have a look at it. You can write out your own table. This 32-bit number for the size of a FAT32 file, that applies to 32-bit only, doesn't work for the 16-bit or 4 bytes. At the offset, 32, 33, 34, 35. So counting from the top left, 0, 1, 2, 3, 15, 16, etc., etc. So learn the offsets and you'll know what to do. This video is really an introduction into the FAT32 file system on an SD card. Whether it varies that much from a thumb drive, I do not know. But it certainly applies to the FAT32 on an SD card. A lot of it is very similar to the 16-bit FAT system. Clusters apply to 32-bit file system as well as the 16. So if you're going to Florida State, that's your lookout. I do wonder why they made that comment, but I don't know. If it's about something other than an SD card, then, and it's something I'm not familiar with, they should point it out on those notes, because otherwise people like me will find it on the internet and say, well, that's wrong. They're not differentiating between any systems, whether it's a thumb drive, SD card, hard drive, floppy disk. And floppy disks, that's where it all started. Hopefully you've enjoyed this video. Hopefully you've learnt a thing or two. It's been a mammoth learning curve for me. I did notice sometimes I was referring to sectors instead of clusters, or clusters instead of sectors. That's what happens when you're trying to do a video, discuss something and do something on the screen. If you liked it, don't forget to give me a thumbs up. If you disliked it, leave a thumbs down. If you've got some comments, or you can teach me the stuff I don't know, leave them down below. Like for example this yellow one. I saw that used in a calculation to find the files, but you have seen today I did not need that number. I've reformatted this 16 gig card with different cluster sizes, and that number 2 still did not matter. So I'm curious, where is it used? If there's stuff I've gone over that you're totally not familiar with, then you haven't seen my FAT16 Series 3 15-minute videos on a FAT16. You should really go and have a look at them. In one of the videos, there's a cheeky method of converting hexadecimal to binary and then to decimal. And it's child's play. An 8-year-old can and does do it. If you want to make a donation for the effort I've put into learning all this and describing it to you, the link in the show more. If I've made any errors and I haven't edited them and put comments in the video, I'll put them in the show more as well, as I have done with my previous videos. If you want to learn more, I recommend MIT or Harvard. Thank you for watching.